So here's your system of equations. And the first thing to do is to rewrite it using matrices. So to write it using matrices, first I want a matrix of coefficients. So can you suggest what that would be? What would the matrix of coefficients be?
That's 2, 4, 1, then -1, 1, -1, 1. That's a 4, right? Yeah,
that's
4.
A 4.
And 0.
Good. Now on the right-hand side, I've also got some numbers, and that's going to be my solution. So that's going to be 2, 0, -2. Okay? And what am I looking for? I'm looking for, and this is not the letter X, it's a matrix X. I just like to write it like this. Let me just see if I can't make it a little bit neater. So matrix X is really X, Y, and Z.
Okay.
X, Y, and Z. Now, written using matrices, this system of equations can be written a little bit more compact. It's just AX plus B, or AX equals B. So let me see here, just grab that. So, whoops. So this system of equations becomes AX equals B. Now, let me just do this as kind of an aside real quick. Let's see here. Just a little aside here, and kind of help you understand what we're going to do. If I gave you something like 7x equals 21, I mean, right away you've already calculated that x equals 3. And you did that by dividing, and that's fine. But let me ask you to think of it a different way. A different way you could do it would be to multiply by the reciprocal on both sides. And yeah, you're still going to get the same thing, right? Because 1/7 of 21 is 3. And then, well, what's 1/7 times 7? It's just 1, right? So I get 1x equals 3, or just x equals 3. And that's my solution. Well, that's with a linear equation. I could do something similar with matrices over here. So are you okay with our linear equation, this example right here?
Yes.
Okay. Let's do the same thing except with matrices. Now matrices are a little bit funnier, but rats. Matrices are a little bit more funny, but you still can do stuff like this. I'm not sure why it's opening up other crap here. I'm going to multiply both sides on the left by the inverse of matrix A. Okay? Now, what's going to happen when I multiply A inverse times A? Well, I'm going to get the matrix equivalent of what I had over here. So what I had over here was I got a 1. And the matrix equivalent of a 1 is called I. A inverse times B. Now, I, which is the identity matrix, times another matrix is still going to give you back your matrix, just like multiplying by 1. So I get x equals A inverse times B. And that's my solution. So basically what I'm doing is I'm getting my solution by multiplying both sides by the inverse. It's this part right here. That's what my solution is. So what's that look like with matrices? Well, let's do that. Let me see if I can't open up program here. I should have Smart View downloaded. TI Smart View. There we go. So are you with me so far on what we did though to set up the solution? We got to multiply the right-hand side by the inverse. That's the big thing here. So
Okay.
let me clear this all out. Let's see. And we're going to go to matrix. And I want to edit. So go to the left one or to the right two. I'm going to edit. Now the dimensions of our matrix are going to be 3 by 3. And now we'll put in those coefficients that I just talked about a minute ago. And we'll have to take a look back at them. I think it was 2, 4, and 1 or something like that. Yeah, 2, 4, and 1.
Negative 1.
Yeah.
1. Negative 1, 1, and negative 1.
Okay, hang on. 2, 4, and 1. Be careful when you put in the negatives. Really? Go to. Negative 1, 1, and was it negative 1 again? Or is it just 1?
Negative 1.
Negative 1. How about the last one? Do you know that one?
104. I mean 140.
140, yeah. Okay. 140. So that's matrix A. Now we want to exit this, so hit the second button and then quit. Get out of there. And let's clear out all this stuff here if I can. No, not sure where the button is. That's okay. Let me go back to matrix. So second matrix. This time I want to enter matrix B. So actually I said enter, which is equivalent to edit. So you go over to edit first and then down to B. B is a 3 by 1 matrix. 3 rows, 1 column. Make sure you always put it in that order. And B was 2, 0, negative 2. So 2, 0, negative 2. So we're good. Now, if you want to, just to be sure of your work, you can hit the second key, then matrix, and press enter. Press enter again, it's going to type out matrix A for you. So you can double check that it is what you expect it to be. I can do likewise with B, second matrix. This time I'll type the number 2. So it looks good. Now a lot of that was just explanation. The actual calculation here is pretty quick. That's my dog Aspen saying hi. He's like, oh, cool, you're doing matrices. I really like this stuff. So let's clear this out. And remember what I need to type in. I need to type in A inverse times B. That's this part right here. That's all we got to do. So once you type in the matrices, the solution is pretty quick. So second matrix, type the number 1 or simply press enter, and then hit the inverse key, which ironically is using the same button that our matrix does. A inverse, and then second matrix. This time I want B, so I'll type the number 2, and bam, there's your solution. So that's it. So it was a long-winded explanation just for this last couple seconds of calculation. So I'm hoping that helps.
That helps, but I don't know what it was about the question that no matter what, I didn't come up with the answer they had. Oh, you know what? Never mind.
Oops.
Maybe I did too much. I'm not sure. But it definitely marked it wrong. They came up with 30 and some odd, because the question was pretty much the same that I got wrong.
Huh.
Like,
Did you understand how we did it though?
yeah.
Okay.
And I remember asking you to explain it to me before, and I'm like, did I not understand? But I see I do understand, so I don't understand how they have the answer they have.
Mm-hmm. Hmm. Yeah, I'm not sure what would be going wrong here. Um, but
But I think they gave me like -30 as an answer.
mhm. Hmm. Uh, yeah, if you find that problem, take a screenshot of it or something like that. Let me know, and I can compare it to what I get when I do the problem.
Okay, because yeah, it definitely gave me like -30, and I'm like, I keep coming up with a fraction.
Mm-hmm. If you do come up with a fraction, sometimes, and what you can do is on your calculator, you can hit the answer to fraction key. So you hit the
Mm,
math key and you press enter. And if I had decimal values, it would turn them into fractions. So,
right.
all right. Well, I hope that helps out. Yeah, I'm not sure what's going wrong with the one that you're talking about because negative. You should have a vector of answers. That is, you should have 3 answers, not just one. So I'm hoping it's giving you more than -30 as your answer, because otherwise, it
Now,
might be looking for an
funny thing,
improvement or something.
I wish I would have took a picture when it said 30 and 7 and some other crap it said in the corner, because now it
Mm-hmm.
doesn't say that. Now it has the answer I put in there.
Wow. I do apologize for all the problems that you're having with WebAssign. It's not been a pleasant adventure for you.
Not at
Mm.
all, but it's okay.
All right. Thank you. Appreciate that. Anyone else this morning? Got some other questions on your mind? Something you'd like to see solved?
Just about the exam. So now we have left to do 10.7
Correct.
before Wednesday,
Mm-hmm.
and then also the preview for the exam.
Yeah, the exam preview
Exam
is
preview.
strongly suggested because what I'm literally going to do is um, take the exam preview and knock out a few problems, and then that'll be your exam. It'll have different numbers, but instead of a problem, say like 7x equals 21, you might have 4x equals 28. It's going to be similar kind of problems, same degree of difficulty, just slightly different numbers. So yeah, I would strongly suggest that you finish up 10.7 and work on the exam review. And if there's some questions, get them answered.
Okay. And the exam, how is it gonna be? We just have one try?
Yes. Yeah. So what I'll
Oh,
do
that's
is,
really gonna.
what's that?
That's not gonna be good.
It's what we gotta. No, keep in mind a
I
couple
know
things.
you have to, but it's just because I'm not used to it, and sometimes I have it right on the paper, but I forget to like add something when I transfer it to the screen, right? And then it's like, oh wait, I forgot to add the one. I forgot to, or I don't know.
Mm-hmm. Mm-hmm. Keep in mind a couple things. First of all, it's not going to count as much as a regular in-class exam. So
Yeah, that's good.
So that's good. Another thing is that I'm going to have you scan in your notes, and if there's one that you got wrong, you're like, look, you got this one wrong, but I really had the right answer, or something like that. Then I can look back at it and see if there's merit for an adjustment or something like that. But the last thing is that you are getting credit for your homework, and you can actually get extra credit for your homework. So there's a lot of opportunity to do well. You've got an exam that's a mirror image of what you're going to see on Wednesday. And what else? You can do well on the homework. you do well on this exam. So I think overall you should be okay. And I'm going to give you extra time on the exam to be able to work on it. So I'll give you 3 hours. I think I'll have and I haven't finished it out. I just got word from the rep yesterday on how to do something. But what I think I will be able to do is give you guys a 3-hour window so that you can start at any time between 9 o'clock and 1 o'clock, and then you'll have three hours to work on it once you start it.
Okay, so that's how it's gonna be?
Yeah.
It's okay.
So the exam is in the morning?
What's that?
The exam is in the morning to
Well,
afternoon?
it's just, I'm going to ask that you start it during our regular class time. So depending on your class, you're either in the 9 to 11 class or the 11 to 1 class. So I'm just going to ask you start it between, say, 9 and noon, and then I'll give you 3 hours to work on it once you start it. Like I said, I just got a little tutorial from our book rep on how to do this. So I haven't set it up yet, but I feel confident that I can do it. That way, if you're in the morning class, you can take the test during morning hours. If you're in the afternoon class, you can take it during the afternoon, or whatever fits your schedule. I'm not really going to look and say, oh, Kim, you're in the morning class. You should have taken it in the morning and you took it in the afternoon. I don't care. You get 3 hours to work on it. And I'm hoping that the extra time will help you double check yourself, make sure you don't make any mistakes, and take care inputting your answers. And if there's a problem, hey, I can always look back at it and see what you did and try and fix anything. So I will be very, very compassionate about working with you on these things.
Okay, so
what were you signing up for?
So once we're done with the exam, we have to scan the notes in and turn it in on D2L?
Yes. Yeah.
Okay.
Yeah. So, Lisa, how are you doing this morning?
Sorry, that's my daughter's name because she was using Zoom for her class. This is Paris Denise.
Oh, hey, Paris Denise.
Hi.
Hey. How you doing? I was thinking to myself, God, I don't remember Lisa. So, well, good morning.
Good morning.
Welcome. Hope you're doing well. Is there any questions that I can answer for you?
I was curious about WebAssign. I know I didn't enter my school email address because it wouldn't let me for some reason. I was just trying to make sure my homework was still getting shown that it was me.
I assume so. I haven't really looked in depth at everyone's score that well, but I mean, if you're posting homework to WebAssign, it'll show up as your name. Yeah, I think I remember seeing Ms. Frombo in there at some point. So, yeah, I'm pretty sure you're in there. But if not, then I'll let you know.
Okay, thank you.
Yeah. So, all right, let's see. I'm going to stop recording here. Some more. Let's see. Where is it? Zoom. No, there. More. So when you have this, distinct linear factor cases, what's going on? For each one of these terms in the denominator, so this one here, you're gonna have a term there, and then another one for this one here. So as another example, if I had 3 over x minus 1 times x plus 5 times x minus 6, then my setup for the partial fraction decomposition would look like this. I'd have, something over x minus 1, something else over x plus 5, and something else over x minus 6. Now, what are those somethings? Well, we don't know. So we'll just put an A, B, and a C. So that's the general setup when you have these, you know, what are called distinct linear factors. That is, they're not repeated. I don't have something like x minus 1 times x minus 1. That you would write as x minus 1 squared. So that's kind of a repeated linear factor because you've got it twice. If you have the distinct linear factors case, it works out really nice. You get something like what I have here, right here. So are you okay with the setup here for the linear factors case? This, just the setup, the distinct linear factors case.
Okay.
Yeah.
Okay, thank you. Now, if you have a repeated linear factor, and you can see that over here, the x minus 4 term is repeated, then our work looks a little bit different. So you start out with the x minus 4 term, and then you have an x minus 4 squared term. So, you know, if you have 2 of them, you're going to have 1, 2 in the denominator. And then the last one is just the x plus 2 term in the denominator. So to kind of bring this example home a little bit more, so suppose I had a 3, x minus 4 cubed over x plus 2, like that. Let me start out with the easy part, which is going to be something over x plus 2. Now, I don't know what that something is to begin with, so I'll call that an A. And then I'm going to have something over x minus 4. But keep in mind, I've got up to 3 here, right? So the next term I'm going to add in is x minus 4 squared. Now, have I gone as high as this exponent yet? No. So what do you think the last term that I'm going to add in is going to be here? Any guesses? Come on, what's the pattern here?
X minus 4 cubed.
Yeah, x minus 4 cubed. And what should I put in the numerator?
D.
D. Now, A, B, C, and D in this problem, or A, B, and C in the one above, or A and B in the top one, these are all unknowns, and you need to figure out what these are. So that's where we have to do some more work. That's also why this stuff is in this section, is because one way to solve these things is by setting up a system of equations. So let's see how that's going to work. And let me just get another page here for us. Let me do that this way. And I think I should still be able to paste in that problem from previous. There we go. Let's look at our setup here. X over x squared. You know, I'm gonna write it factored. I'm not gonna write it like they wrote it. So x minus 1 times x plus 8. That's a really awful looking 8. There we go. Equals A over x minus 1 plus B over x plus 8. Now, the idea here is to solve for A and B. And the way to do that is, in my mind, to clear out the fractions from this equation. What can I multiply by that will clear out the denominators? What's the lowest common denominator here? Anyone?
X minus 1 and x plus 8.
Thank you, ladies. X minus 1 and x plus 8. Now, when I distribute that, let's see here. What am I going to get? I'm going to get, on the left-hand side, can you see that I'm going to get everything to cancel? That'll cancel with all this stuff that I'm multiplying. So this has to multiply here, and here, and here. It's going to multiply all three of these terms. On the left-hand side, when I multiply this, and I'll tell you what, let me just write it out a little bit more lengthy. All right, come on. There we go. So this is going to multiply. I'm just curious. Can you hear my dogs downstairs?
A little bit.
Yes.
A little bit? Okay. All right. X minus 1, x plus 8. A over, excuse me for just 1 second. Hello? Okay, sorry about that. X minus 1. And then I'm going to have my LCD up here. X minus 1 times x plus 8 plus b over x plus 8. And then x minus 1 times x plus 8. So all I've done is I multiplied both sides by the LCD. And the nice thing about doing that is I get a lot of cancellation. Oops. This will cancel. This will cancel. Over here, just one of these is going to cancel, and just one of these is going to cancel. So let's take a look at what I have left. What I have left is, well, you tell me what I have left on the left-hand side. What's left after all this mess?
X.
Just an x. Equals a times x plus 8 plus b times x minus 1. Now there's two ways to solve this. Okay. I'll show you the first one really quickly, and then you can ignore it, okay? Although it's really kind of helpful to understand a little bit of what's going on. On the left-hand side, I'm just going to leave that alone for the moment. But on the right-hand side, I'm going to distribute. Now on the right-hand side, let me bring these things together a little bit. Now that I got them, because both these terms involve an x, right? And then both these other terms don't involve any variable. So, okay, that's fine. This is going to be x equals ax plus bx plus 8a minus b. Okay, one last thing here. I'm going to write that as x plus 0, or maybe 1x plus 0 equals a plus b times x, so I just factored out the GCF there, plus 8a minus b. Do you see where this one's going? Or do you see what I did here? I'm not going to ask you if you know where I'm going yet. But do you see where I got all this stuff? It's a good chance to ask some questions. So. All right. the way you get an equation here is this. On the left-hand side, what's the coefficient of x?
1.
1. What's the coefficient of x on the right-hand side? Well, what's in front of the x on the right-hand side?
A plus b.
A plus b. Now, let's do the same thing for the constant terms. On the left-hand side, what's the constant term on the left-hand side?
0.
0, thank you. So what this gives me is a system of equations. So it gives me 1 equals a plus b, and 0 equals 8a minus b. So that's why this is included in this chapter, is because it gives you a system of equations if you solve these things correctly. And here, I'm trying to think. I mean, you can solve this any way you want. You can do Cramer's rule, you can do graphing, you can do substitution, you can do elimination, you can do Gaussian elimination, you can use the inverse matrix, and there's a lot of ways you can solve this. For me, I guess it just looks like this: b equals 8a. Just by moving that term to the left-hand side. And if I put that on here, I get 1 equals a plus 8a. And that gives me 1 equals 9a. So 1/9 is a. Yeah. And if 1/9 is a, I can plug that in here and get b. B is 8/9. Oops. It's a great looking 8. Too bad I need to write a 9 there. 9. So that would be your solution. Now that's kind of a long way. I'm going to show you something that the book probably doesn't show, and probably the videos don't show. So let's go back to right here. Let me see if I can't heat a little bit. So this part, right here. And I'm hoping that you're okay with what we did to get there. So let's lasso this. And copy. All right, so let's add a new page. And see if I can paste that. Paste. Ah, that worked out cool. That was really cool. So assuming you're okay with what we got this, let's realize that this equation holds true for any value of x. So I'm gonna pick a very convenient value for x. I'm gonna pick, let's say x equal 1. Let's see, x equal 1. And let's see what happens when we set x equal to 1. So if I set x equal 1, on the left-hand side I get 1 plus b times 1 plus a, excuse me, not b, a. Thinking ahead. A times 1 plus 8 plus b times 1 minus 1. Do you see anything nice that's going to happen when we simplify this? Anything at all nice going to happen?
It cancels out.
B is going to cancel out. That's just going to be 0. And so the equation I'm left with is 1 equals, what's in the parentheses? What's that simplify to?
9.
9 times a. So what does A equal?
9.
Try again.
1, 9.
There you go, 1,
Oh
9.
yeah, I'm sorry.
It's okay. But do you see why this worked out nicely? It's because that choice of X canceled that term out. That's that stuff I have in the yellow here. So that was a nice
Can you
choice.
always set X to 1?
Say again?
Can you always set X equal to 1 to
Yeah, I
solve
mean,
it?
this holds true for any value of X. In fact, we've got to do this again because we only figured out what A is. Is there another value that I can choose to set X equal to that might be equally as helpful? Something that would cancel out the A and let me solve for B, maybe?
-8.
Yeah, -8. Set X equal to -8. And let's see what happens here. So guide me through this equation. It'd be -8 equals A times what?
-8 plus 8.
-8 plus 8 plus B times,
-8 minus 1.
thank you. Now, kind of like before, this term is 0, right? So that's good because that drops out. It means I don't have to worry about that. This turns into -8 equals -9 times B. -8 over -9 simplifies to 8 over 9, and that's B. So I'm getting the same thing as before. So my final answer could be written like this. Let's see, you'd be 1/9 over X minus 1 plus 8/9 over X plus 8. And that's going back to my original problem for that. Typically speaking, they'll probably put the 9s in the denominator. So we could also rewrite that as 1 over 9 times X minus 1 plus 8 over 9 times X plus 8. So just take the denominator of that numerator fraction and put it in the denominator of our primary fraction. So that's it. Now, what should you know and be comfortable with? Well, let's look back here. You should know how to set these things up. So like we did in the linear factor case right here. And you should also understand it in the repeated linear factor case. And I think, let's see. Yeah, here it is in the repeated linear factor case. Repeated linear factor case. Now, if this were a face-to-face class, I'd be making you do one of these. And there's actually another case beyond this as well. It's called the prime quadratic case. But look, this is not what we're expecting, so I'm going to go a lot easier for us. You should know how to set up the repeated linear factor case, which is this. And that's fine. That's all I'm going to ask you to do for the repeated linear factor case. And then you should be able to solve like we did here for A and B up in the top. So let me get back here. Let's see. No. This. You should be able to solve for A and B. Once you solve for A and B, you put those in. And that was right here. And then I rewrote it like this. All right. So that's what I want you to be able to do for the repeated or for the distinct linear factor case is solve. And I'm not going to give anything harder than that. All right, any follow-up on that? We went through a lot. I think there's some examples on my YouTube channel as well, so please check those out. But anything else here?
I have another question about the previous chapters with the multiplication of matrices, right?
Okay.
I pretty much did those. I mean, I watched the videos, both of them, and I pretty much did those on the calculator. Yeah.
Sure.
Will we have to, like, for the exam, will we have to, like, actually write them out?
No, I don't think I'm going to ask you to do that. The one thing that you should be aware of on the exam is this dimensions, so that if you have A is a 3x4 matrix and B is a 4x2 matrix, you should be able to come up with the dimensions of the product. So if the inner indices match, then you can come up with the dimensions of the product. The dimensions of the product would be, call it matrix C, which would be a 3x2 matrix. Or you should see that if I multiplied B times A, which is a 4x2 times a 3x4, you should be able to look at that and say, well, wait a minute, there's a problem. Why is there a problem?
They don't match.
Yeah, these don't match. So if they don't match, then you can't do it. Now your calculator will tell you, it's like, well, wait a minute, these don't match. But you shouldn't have to put them into your calculator to figure out you can't do this one.
Okay.
So yeah, there's not much, you know, again, if this was an in-class kind of thing, face-to-face, I'd be asking you to show me that you can do one of these by hand. But I'm going to settle for making sure that you can do them by working with the calculator. Okay?
Okay.
Great, great. Anything else, ladies?
I think that's it for now.
Okay, I'm going to pause the recording here and wish you good luck.